Okay, this lesson, this is kind of just a precursor before we get into the book. This one is, we're just going to take a look at lines and a different way to graph lines than what you're used to. But first, we're going to refresh our idea about transformations with our functions. And so we'll start with the parabola. I know we spend a lot of time graphing the parabola, and you guys are usually pretty comfortable with that. So remember, in vertex form of your parabola, your A represents your vertical stretch or shrink. And then the H is your how your graph moves left and right. So that's your left and right transformation. So this is left and right or horizontal. And then the K is your vertical translation or up and down. So in this particular problem over here, I have graphed the parent function. This is just the parabola y equals x squared. You can see the vertex is at 0, 0. And the pattern, remember, on our parabola is 1, 3, 5, 7. It goes up 1, over 1, up 3, over 1. So that means the A is 1. There, it's not stretching or shrinking. It's just following the normal rate of change. And so that's our equation for that particular graph right here, y equals x squared. Okay, so let's use our transformation here. So we want to graph the parabola x minus 2 quantity squared plus 4. So first thing we're going to do is find our vertex. Remember, our vertex is 2, 4. We're going to move right 2 and up 4. So right 2, up 4 puts our vertex right here. A is right here. A is 1, so that's just going to follow our normal rate of change of 1, 3, 5, 7. So up 1, up 3, and there's our graph. Okay, same thing now with absolute value. So remember, the absolute value is a V shape. So here's our A, H, and K. So the vertex of this absolute value is at -1, -3. So we'll come over here at -1, -3. And then our rate of change, A, is 2. So that means it's going up 2 over 1. So up 2 over 1, symmetric. Up 2 over 1. And there's our absolute value. Oops, I missed. Let's try that again. And there's our V shape. Okay, now we're going to do the same thing with a line. So if you look at this equation right here, y equals 3 times x minus 4 plus 2, this is your A, this is your H, and this is your K. Well, you guys are probably used to, instead of the vertical stretching and shrinking, that average rate of change, that's going to be your slope. And then H is going to be a starting point. So this is HK, this 4, 2 is going to be a starting point. So you guys are so used to using y equals mx plus b to graph a line, which works. But what's your starting point on y equals mx plus b is a y-intercept. It's something, I'm just going to make this up, it's something that the x value is 0, so it would look something like this: 3 times x plus 0 plus 2. See how that's your starting point right there? 0, 2, that's your HK. Same thing over here. So if we were going to, and you guys have seen this formula before, but it's been written as point slope form. So basically what they've done is they've taken, this is point slope formula down here on the bottom, right here. But if you take this formula right here and you add the y1 to both sides, now look what you have. You now have our transformation HK formula. It's just different letters. I don't know why they use different letters. It's all the same thing. Here's your A, here's your H, and here's your K. So instead of multiplying out this equation at the top and putting it in y equals mx plus b, we're just going to graph from this point right here, 4, 2, and up 2. And then what's our slope? Our slope is 3. So we're going to go up 3 over 1. And there's our line. So we can graph anything with our A, H, and K, our transformations. We can use all of that. So this one says graph and write the equation of a line with the given information. Use the idea of transformations. So point slope is what you're used to, but we're not going to put it in point slope. We're going to put it in our HK format, remembering that this is the point and A is the slope. That's our average rate, that's our change, our average rate of change, right? Our vertical stretch and shrink. So we're going to say 3/4, and then we're going to go x minus 2 minus 5. And that is an acceptable equation. You could write it like that, and I would know exactly what it is. I would know how to graph it. Come over here, 2, negative 5, and then up 3 over 4, down 3 over 4, like that. Okay, this one says write the equation for the line that passes through the given points. Use the idea of transformation. So once again, we need an A, an H, and a K. Remember, A is your slope. That's your vertical stretch and shrink, your rate of change. So to find the slope between two lines, we're going to do a difference in y over difference in x's. So 4 subtract negative 3 over 5 subtract negative 6. We end up with 7 over 11, so there's our slope. So we could pick either one of these 2 points, it doesn't matter. We could write both equations, y equals 7 over 11 times x minus 5 plus 4. That's an okay answer. Or we could write y equals 7/11 times x plus 6 minus 3. That is also acceptable. Those are 2 equations that would graph the line that goes through those 2 points. And that's using our idea of transformations, our A, H, and K. Okay, that's it. It's pretty quick.